All right, so we've created 5 ordered pairs. Now we want to draw the graph on a coordinate plane. So I'm going to draw it by hand first, and I'll show you how you can do this with the graphing calculator just to get the general idea of using that graphing calculator. So I've got a coordinate plane there. X-axis goes left to right, y-axis going up and down. And we're going to plot those points. So -2, +2 is right there. -1, +1, 0, 0, 1, 1, and 2, 2. What kind of shape is that? It's like a V, yeah. Left side was a little longer than the right side. It doesn't matter, but just to kind of ease the stress levels. We got a V shape. Every absolute value graph that you see should be a V shape. What we're going to be doing today is taking that picture and we're going to pick it up and move it around based on a set of rules. Okay, we're going to stretch it, make it wider, make it skinnier and taller, that sort of thing, based on a set of rules without having to make a table every single time, because that's long and tedious, right? You don't want to have to do that every time. When you're graphing lines in Algebra 1 in 8th grade, you didn't make a table for every line you drew, right? You had a format. You had a slope-intercept form, and you would put the dot on the y-intercept and then count the slope. It was quicker than making a table. We're going to find a quicker way to do this, okay? So let's glance at this graph on the graphing calculator. I'll show you how to do that. So if you got your graphing calculator, great. If you don't, it's okay. Still doing it by hand. So to graph something with your graphing calculator, you want to hit the y equals button, which is at the top left, right underneath the screen. It's highlighted in red there on my screen there. I've got this big crazy polynomial that I have no idea where it came from. So, but if you've got anything in your y equals menu, any of these equations, just hit clear, arrow down to whichever one there's something in, and hit clear and get rid of it so you don't have that issue going, okay? Also, you want to notice this plot 1, plot 2, and plot 3 at the top. Turn those off, and the way you do that is you just arrow up to whichever one. If they're darkened in, that means they're turned on. So like that's what they look like when they're turned on. You want to turn those off because it can affect the graph of a regular function, because it's a statistics analysis thing that you can do with this that we'll get into later on in the semester. But anyway, we're going to turn those off. You just arrow up to the one that's darkened in, make sure it's blinking, and then hit enter, and it turns it off. Okay. And then I'm going to put in that absolute value of x. So to do that, to get the absolute value with the calculator, you can hit the math button. And then we take the absolute value of a number. So we press over to the right. And that first option, ABS, stands for absolute value. And I just hit enter. And if you're running the newest operating system, so if you got one of the color ones or one that you rented from us, it should change it over to absolute value marks. If it doesn't, it may just be a setting that we need to fix, or don't have to fix, but we could. If you're running an 83, it'll say ABS parentheses. Means the same thing. Okay. So we just put an X in that place, and to get that X right here beside alpha, hit X, and it goes in there. And then I'm going to hit graph, top right button, and it's going to draw that beautiful V-shaped graph. Get a dimension mismatch. Turn the plots off. Turn your plot. And press to the right to the number, and there it should be over there. And it's in it. Anybody else having trouble? Where you going? You're draw. Anybody else? All right. Okay, so we've seen the graph. What we're going to be doing today is transformations on the absolute value graph. Is really an easy one to do transformation with. Parabolas that you covered in Algebra 1 are also very easy to do transformations with because they have a nice vertex point. Where would the vertex of that graph be? 0, 0 at the corner there, yeah. Because remember in geometry, the vertex was a corner of a figure. Well, vertex is a specific place on a graph of a function with the absolute values. This corner here with a parabola. Y'all remember doing that in Algebra 1. A parabola had a vertex, down at the lowest point or the highest point if it were in that direction. Those make it easy to do transformations with because really you can take that vertex point and then move it whichever way you need to move the graph around. So that vertex point is kind of the center point of the graph, that idea. So the vertex is pretty important here. So we're going to look at that form with absolute value equations. So we're going to do the general form of absolute value functions. Okay, general form, absolute value functions. This is something you will need to know. And if I say you need to know it, that means I'm not going to give you the formula. Okay, so you'll need to know this. And after you've used it a few times, it's not hard to know. It's pretty easy. The letter A, then the absolute value mark, x minus h. Another, close up the absolute value marks, plus k. That is the general form for a absolute value function. It looks a lot like vertex form of a quadratic. Remember that from Algebra 1. If you don't, that's okay. We're learning it now. Okay, so it looks a lot like that. The key is that you can get the vertex right out of the equation. The vertex is going to be at the ordered pair h, k. Okay, whatever's added or subtracted to inside the absolute value, that's going to be your x value of your vertex. Okay, notice it's a minus sign there and it's positive h out here. It changes signs. And then k, whatever's added or subtracted out here, is the y value of your vertex. So if it's plus 5, it would be positive 5 for the k. If it's minus 5 on the outside, it'd be negative 5 for the k. The h changes signs, and we'll see some examples of this, and you'll start catching on to that. All right. The a value in the front, the leading coefficient, I guess would be the best way to say that, determines which direction that V shape goes. If A is positive, how does that say that A is positive? Because A is greater than 0, right? That means it's going to open up. So it's going to look like that. It's a V opening up if A is positive. If A is negative, opens down. Yeah, that V shape opening down based on that. Okay. That A is also going to denotes the slope. It denotes the slope on each side because that V, if you start at the vertex, you've got a line going one direction, line going the other direction. It's like a slope on each side. So that A value is going to tell us how to count that slope, rise over run type idea. So if it's opening up, we're going to count up and over. If it's opening down, we count down and over to get that slope of that. Okay. So general form, got the vertex involved in there, got A telling you which direction it opens and all that. So that's going to help us in just being able to quickly get that information and draw the graph of a absolute value function just by knowing those things, okay? So let's look at an example of that. So we want to graph f of x is equal to 2 absolute value of x minus 3 plus 4. So when I'm doing this, I want to kind of take you through the thinking process that you want to use. You want to think first, what's the vertex? Because that's the most important point on that absolute value graph. So what's the vertex of this one based on the general form we just talked about? Well, I know out here, that right there, that plus 4 tells me that the y value is positive 4. And then the x value won't be negative 3, but it'd be positive 3, because remember, it changes signs on the inside. Okay. So vertex is going to be at 3, 4. Which way is this thing going to open? Up or down? Why? Because that 2 in front is positive. Yeah, so it's going to open up. And I'm just going to point an arrow up like that. Okay? Those are the things you want to think about. And those are things that I might ask on the quiz over this section is, what's the vertex of this function? And you would have to know that general form, pull that out. What direction does this function open? That sort of thing. Those are things that you're going to need to be able to pull out of these. So I'm going to draw a coordinate plane here. I know the vertex is going to be at 3, 4, so that's up in the first quadrant. So when I draw that, I want to kind of make sure I got room to get up to 3, 4, and then it's going to open up. So I need some room above that as well. So I drew with a lot of first quadrant in my coordinate plane there. So go to 3, 4. That's where the corner's at. And we're going to want to draw the slopes. The slope is indicated by what? The 2, the 3, or the 4? Close, but no. Jonathan has eliminated one choice. We have 2 left. 2. 2 indicates the slope. And since it's opening up, we're going to start at that vertex and we're going to count up 2 over 1. So we're going to think about that as a fraction, 2 over 1, like a slope of a line. Okay? So we're going to go up 2 and over 1. Up 2 and over 1. I just do that a couple of times to the right. And then from that vertex, I'm going to go to the left a couple of times. So I'd go up 2, left 1. Up 2, left 1. And I get... And yeah, I thought I could draw a straight line, but I can't. So I'm going to use a rule. I get that nice absolute value graph. Opening up with a vertex of 3, 4 out of that. Okay. So based on just knowing that general form, we can build that. Okay. Questions about that one? We're going to do some more, but I just want to kind of get the start. Okay. You guys are quiet this morning. All right. Let's do another one. G of x. 1/2. Let's make that a negative 1/2. Absolute value of x plus 2 minus 5. And again, the things you want to think about and be able to produce are the vertex and which way that thing opens. If you can get those 2 things, then the graph is easy. Okay. So the vertex, based off our general form, -2, -5. Why is it -2 again? The sign changes on the inside. Perfect. -2, -5. It does not change signs on the outside. Okay. All right. Which way is this thing going to open? Down. Because it has what? A negative where? Which letter is it? I know that seems picky to say which letter it is, but it's going to be important. A. A is negative, so we're going to go down with that. Okay. All right. So Got those things happening? So let's go draw our coordinate plane. We know -2, -5 is in what quadrant? I'm trying to review you as we go with 3, quadrant 3. So we need a lot of room in quadrant 3. So that way I don't waste a whole lot of space on my graph. Okay. So -2, -5. So go to that point. 1, 2, 3, 4, 5. There's the vertex. And maybe I make that point a little bit more bold than the others, just so I know that's where I'm going from. Now, how do I count my slopes? Do I go up 1 and over 2 or down 1 and over 2? Why am I going down again? Because it's negative, okay? So -1 over 2. -1 over 2. I could do that as many times as I wanted to. I did 3 times on that one. That's okay. It's not a big deal. So that's going to the left. Now I'm going to go down 1 and over 2 to the right. Down 1 over 2, down 1 over 2. And I've got that nice symmetric D shape on. Spreads it out a little bit. That small fraction in the front is what makes that wider. We're going to talk about that in just a minute with transformations. But those numbers, that A value has a lot of weight in how wide or skinny the graph is on an absolute value graph. Okay. Let's look at one more. Example D. H of x. What's h of x mean again? Just y. Yeah, just whatever y is. Okay. So it's a y at a certain x technically, but it just means y. So if I wrote y equals and then you had a function, it's the same thing. Okay. That's a little bit more descriptive, saying, hey, this is a function, and that means it passes what test from Algebra 1 to decide if something is a function? What test decides if a graph is a function? Y'all remember that? Been a while. It's a line test, vertical line test. So if it says it's a function, that means it passes the vertical line test. So yeah, that is a function. It passes the vertical line test. We draw the graph, we'll make sure of that, but it does. Okay. All right. So this one's a little bit different. Got -3 absolute value of x, and then a +4 on the outside. So what's our vertex? What would the x value be? Is there a 1 subtracted from the x on the inside? No. What is subtracted from x on the inside? Nothing, right? It's math class. What's nothing in a math class? 0. Oh, so it's like there's a -0 on the inside. Okay, so it'd be 0, 4. Okay. Now, if there were nothing in front here, that would be a 1. But on the inside, we're looking for something added or subtracted. So that's where the 0. If there's nothing there, it's a 0. Okay, and this is going to open which way? Down. That's a -3. It's going to open down. Where is 0, 4 located in the coordinate plane? Is it in a quadrant? If so, which one? If not, where is it really at? On what? Say it again, Nick. Which line? X-axis or Y-axis? Close. It's the Y-axis. It's on the Y-axis because the 0 is on the X and the 4 is on the Y. So you go up here to 0, 4, and that'd be where your vertex is at. It's on the Y-axis. There. And then how do we count our slopes for each side? Up or down? Down 3 over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1. So that 3 that was in the front made the absolute value graph skinnier. All right, so a bigger number in the front as a, shrinks it this way or compresses it maybe horizontally, or maybe it's a vertical stretch. Y'all ever play with silly putty where uh, we used to do this a lot when I was a kid, so we didn't have Instagram, Snapchat, stuff to do. So, like the newspaper would come in, you take that silly putty out, and you make a pancake with it, and you put it on top of the picture, of Garfield or whatever, Calvin and Hobbes, or whichever one of those guys you wanted to do. You'd press it down, and then you pull it off, and the ink would come off onto the silly putty, and it had the exact picture there. And then you could take it and you could stretch it out or make it wider, all that stuff. So that number in front, that big 3, is like stretching it this way. So if you had that picture of Garfield on there, Garfield was kind of a chunky cat, so you could make him skinny by just pulling that silly putty like that. It made it skinnier, and you could then press it down and then make them, squat together and make them wider. Okay, so that's what that does. That number in the front does that sort of stuff. We're going to see that as we talk about these transformations over functions. All right, so let's dive into that, transformations. Still in the same section. It's so related to how you do things with absolute value graphs, so they put it together. Transformations. We're still going to do some stuff with some graphs, but if you want to write some of this information on notebook paper and then do the graphs on the graph paper, that's fine. It's your stuff. So there's that A value again, and then F parentheses X minus H close parentheses plus K. Okay, so here we're saying, okay, this is a transformation on a function. This function f of x, subtracting h, that's going to move left or right. Adding k is going to move up or down. The a value is going to do the same thing that it did with absolute value graphs. It's going to, flip it up, opening upward or opening downward. It's also going to stretch or shrink that. So let's work on that A. A, it opens up if A is greater than 0, down if A is less than 0. We know that about absolute value graphs. We also know that about quadratics. Well, not really focusing much on either of those during this special section part here. But that A also does some things. So the absolute value of that A, if it's greater than 1, so that means if it's a bigger number, like 5 or 4/3, it could be a fraction and still be a bigger number. So if that is greater than 1, then it's going to be a vertical stretch. And these are things you're going to need to know. Okay? If that value is between 0 and 1, what kind of numbers are between 0 and 1? Decimals, what kind of decimals? Like, give me some examples of numbers that are between 0 and 1. 0.2, that's also 1/5. So a fraction 1/5 or 0.2, both the same thing, both between 0 and 1. 1/3, 7/8, any small fraction, basically, is what we're saying there, that it's a small fraction. And if that's a small fraction in there, it's going to be a vertical compression. And you may hear me say shrink. Shrink, compression mean the same thing. It's going to make it shorter, that sort of idea. Okay. So A decides that. H is going to be a horizontal shift. Okay, so that H in there is going to shift it horizontally every how many units that is. So if that would be X minus 5 in there, you're going to shift to the right 5 units. If it were H plus 3, you would shift to the left 3 units. And we're going to see that as we go. Remember, it's the opposite on the inside, just like it was the opposite on the inside with the absolute value graphs. Okay? The K is going to be a vertical shift. up or down. It's going to move the graph up or down. What we're going to be doing in this section is we're going to take just some basically random graph, and we're going to do these transformations that they're asking for and describe what's happening. So let's look at some examples of that. Let's first get an original graph that we're going to use. We're going to use this one for the next couple of examples. Actually, the next 3 examples. The original graph will be given to you, and this one, it's not, they do this on purpose to get you to understand the transformation part. It's not a function like y equals x squared or something like that. It's just this, they put something together and put some points together. So this one starts at 0, 0, goes up to 2, 3. So there's 0, 0, 2, 3, and then goes over to 5, 3. And then they connect that with a line like that. So this is the original graph. And it's not, they purposely do not give you the equation of that because this would be a weird equation for sure. It'd be a piecewise equation. But the idea is that that's a function because it passes the vertical line test, right? So we're going to do some transformations on that function. So that's what we want to do. So we want to graph the transformation. All right. I think we're on example E of the section. This is f of x over here. That's what we're calling that. That original graph is f of x. You got 3 ordered pairs in there, so that's going to be helpful when we start moving those, so we can see, oh, we're going to move those x values over 5 units, up 5, that sort of thing. We're going to look at those points as being useful in doing that. So let's do this graph. Y equals 2 f of x plus 1. Okay. All right. Now, here's what we got to think about happening here. The plus 1 is doing what to the original graph based on all this information up here? The plus 1 is moving it which way? Vertically or horizontally? Vertically. Up 1 unit, right? So it's like taking this picture and picking it up and moving it up 1 block. Right? Okay. Now, what's the 2 doing to it? Not horizontal. It's multiplying on the front, right? So that's A, right? That 2 is in the position that A is normally in. What does A do when it's a 2? And it's going to open up. It's not going to flip the graph over or anything. It's just going to stay like it is. And then the 2 is a bigger number. It's bigger than 1. So it's going to be a vertical what? Stretch. It's going to make this thing taller is what's going to happen, okay? So if we, think about order of operations, which one would happen first, adding 1 or multiplying by 2? Multiplying by 2. Because order of operations, we did this in Algebra 1 on Friday. Multiplying comes first. So we're going to do that 2 first. What's the 2 multiplying by? What's that? It's y. What do we have as ordered pairs? We got x's and y's, right? So we're going to double the y values, and then we're going to add 1 to move them up. So our new graph is going to look a little different, but very similar. It's not going to change the whole look of things. So I'm going to move the... Now, let's do this for each ordered pair that we know. We know 0, 0. If we double the y value on 0, 0, what does it become? Be 0, right? So 2 times 0 is 0. And then we add 1 to move it up 1 unit. So this new point would be 0, 1. Let's take this ordered pair. Remember the order we're doing this in. The multiplying comes first. So 2 times the y value would make that point at 2, 6. And then we're moving up 1 from there. So that would be at 2, 2, 7. So this is at 0, 1. This is at 2, 7. And then this one, 5, 3. It's got the same y value as that one, so it should be the same new y value at 5, 7. Now we have our new graph based on those transformations. And these transformations are something we're gonna touch on transformations pretty much in every chapter that we talk about graphs and things in. So we're doing those operations. Remember, f of x just means y, so that's doing that to y, making y happen that way. So the plus 1 is shifting the graph up 1 unit. The times 2 is doubling the y values. Remember, order of operations made that happen first, and then we moved it up 1. Okay. A little bit mind-boggling if you think too hard. We're going to start back with the original graph for the next example. So we're going back. This is our graph that we're going to do the transformation on. Okay, going back to that original graph. And let's do this transformation. Y equals f of x minus 3 plus 2. Okay. And we want to say what each of these things is doing. So there's not a multiplication happening on this one. So we know it's not going to have a vertical stretch or compression. It's just going to shift. Looks like both ways, horizontally and vertically. We got some experience with the plus on the outside, so that's going to shift it which way. So move it up 2 units, right? That's what that does. Now here's where the opposite happens on the inside. That's x minus 3 on the inside. So it's going to move it right 3 units. It goes the opposite direction. Okay. Instead of a minus 3 would normally move to the left, but because it's function transformation, it's the opposite. It's happening on the inside. We're going to move to the right 3 units. Okay. So new graph. If I move, remember our ordered pairs are 0, 0, 2, 3, and 5, 3 from our original graph. That's where I got those. If I move this one right 3 units and up 2 units, where does it go? 0, 0. It starts out here, and if I move it to the right 3 units, 1, 2, 3, and then up 2, 1, 2, it ends up at 3, 2, right? That transforms 3, 2. What does this one become? 5, 5. 4, 5. Okay. 5, 3 becomes right 3 units, so that'd be 8. Up 2 units would be 5. 6, 7, 8. 1, 2, 3, 4, 5. And there we have our new graph. Shifted horizontally and vertically. If you notice, if I were to take this original graph and pick it up and bring it down here, I'm trying to do that. Since I'm on the same size graph paper, It's like I took this graph that was originally here and picked it up and went up 3 units, or up 2 units, and over 3. And it lays right on top of it. That's what I'm doing. I'm taking this graph and I'm picking it up from where it was originally and moving it over 3 and up 2 and getting it to land on the graph there. So it's taking that original graph and transforming it a little bit. That's what we're trying to do here. And then just don't want to do that. And part of what I'm going to ask you to do on like a quiz or something is I may give you, okay, here's a transformation. Tell me what it did. Not even ask you to draw it. That idea. This is something that the graphing calculator is really not helping you with. Here's why I'm not showing you anything on it, because it's not really helpful for doing this stuff. So if I gave you this, we're going to draw the graph in a minute, but let's first just talk about what it does to a graph. What transformations are taking place? Well, what does this one do? What does the -4 do? What's the -4 do? Moves it down 4, right? What does the +2 in the inside do? Okay, which means it's moving which direction? Left 2. Inside is going to be, remember, inside is horizontal. Outside is vertical. That's going to be the case no matter what kind of function we deal with later on. We get to quadratics and start talking about doing this, or cubics or whatever, or absolute value graphs, square roots, cube roots, all those same rules apply. So left 2 units here on the inside because it's +2. This negative out in front, ooh, that's the new thing. What does a negative do? Technically, what is A in this problem? It's -1, right? So the negative A value makes it do what? Open down, which means it's going to flip the graph over. So we're going to take our original graph. So this would be, it's the math term for that is a reflection across the x-axis. That's the math term for that. Hopefully in geometry you may have talked about some reflections, transformations in figures where you reflect it across an axis or something. But that negative in front is going to reflect it across the axis, the x-axis in our case. Okay, so we're going to take that original graph and try to draw what's happened here. And remember, we're going to use those 3 ordered pairs that we know about: 0, 0, 2, 3. Go back up here and 2, 3, and 5, 3. And we're going to talk about what they become based on these transformations that we've described here. And again, think order of operations kind of stuff. And we're going to take that and transform. So if I reflect 0, 0 across the x-axis, does it move? Where's 0, 0 at? On the x-axis. Technically, it's on the y-axis too. But it doesn't move any if I reflect it. But then if I move it left 2, what's the x value become? -2, right? Because if you're going to the left from 0, 0, left 2 would be here, right? -2. And then down 4, and it's going to be right there. Okay, so we have -2, -4. Now, 2, 3 little bit different because we've got some numbers in there. So when we reflect 2, 3 across the x-axis, 2, 3 is right here. If I reflect it across the x-axis, it's going to go down here at 2, -3. And then I'm going to move that point left and right. So I'm moving it left 2 units and down 4 units. Should be right here. Okay, so we have 2 negative, or -2, -4. So I went from there, left 2, down 4. 1, 2, 3, 4. It's right there, which is the point 0, 5, 6, 7, -7, 0, -7. And again, 5, 3 is going to have the same y value. If I'm transforming it, it should have the same y value as this point here. But just think about it. 5, 3 is here, reflected across the x-axis. Would put it down here, just changes the sign of the y value. And then I'm moving it left 2 and down 4. 1, 2, 3, 4. Right there. And again, it ends up on the same horizontal line as the 2, 3 point ended up. So that's at 3, -7. Is that point there, and we would draw that, and that would be the transformation upon the graph of the transformation for that function. Okay, so the idea here is that you learn how to describe those things, and the graphs are going to be can get a little twisted sometimes because you're overthinking things a little bit. But if you can do this part, this is going to help you a ton, because then you can take ordered pairs and say, okay, what happens when I do these 3 things to that ordered pair? And that helps you with the graph. So if you can describe which transformations are happening, and again, this is going to come up again when we start doing quadratics a lot in here, cubics, square root functions, those sort of things. When we start doing those and we talk about the graphs, we're going to refer back to these transformations. So make it a point to try to learn these transformations fairly, I'd say fairly, but I'd say completely know what each piece is going to do. It's on the inside, it's going to be a horizontal left, right. It's on the outside, added or subtracted, it's going to be vertical up and down. Multiplying on the outside is, if it's a negative, it's going to reflect it or flip it over, open it down or open it up. And if it's a big number in the front, it's going to stretch it. If it's a small number in the front, it's going to shrink it. It'll make it shorter, more squatty. And it may, when it shrinks it, it may make it look like it widens out some, which it should. If you push something down, it's got to go somewhere. Okay. So that being said, we got about 30 minutes left in class. And here's how we're going to do things. I'm going to try it again this semester, doing it this way. You've got time in class to work today. You won't always have time to work in class the day I'm teaching. Today you do. But tomorrow you'll have a work day. And what that means is you don't have to do this at home tonight unless you want to. And then tomorrow you'll get time to work in class, ask all the questions that you need, get help, check answers. I'm going to have my textbook. I'm going to get it in a second, put it up here so you can check answers and look at things. And then Wednesday when we come in, 8 o'clock, we'll have a quiz over this stuff. And then I'll teach the next lesson after that quiz. So the quizzes are timed. ACT's time, so it makes sense. So quiz on Wednesday over this stuff. Tomorrow's a work day. The work that I want you to be working on in this section, page 127, 3 through 26 is what I want you to look at. And I've got graph paper up here if you need it, straight edge if you need it as well. And those are the things I want you to be working on for this section. Again, focus on memorizing the general form for an absolute value graph and the transformation stuff too as you go. If you're using it and you're trying to do what you're supposed to do instead of kind of guessing at it, you're going to learn those anyway, and you'll have them memorized without even realizing you're trying to. Okay, so I don't mind you working together. Don't get too loud, or ask questions. I'm going to be around, so come up, ask questions, whatever you need to do, and You got 30 minutes to work today. Like I said, that won't always be the case, but you get I'm doing a work day tomorrow, quiz Wednesday, and we're just going to try to go that pace throughout the semester if we can, and do our best at it. All right. Hey, Toby. Yeah, if you got your earbuds, you can listen to music while you're working and stuff. That's fine. Thank you.